Hi, we're going to go through the quiz preview for tomorrow's quiz in its entirety, going back through some of those things maybe you forgot since it's been a little while, or maybe you just didn't quite get it the first time through. So hopefully we'll take care of those things for you here. First, we're going to look at graphing some parabolas. Now remember, when we're graphing parabolas, especially when they're in standard form, I've got to be able to figure out my center point, my vertex right away. Which again, the way we do that is by using the negative b over 2a to find my x value. So here, my negative b, or my opposite of b, would be negative 2. 2 times a, my a value being negative 1 because of the negative in front of my x squared. So 2 times negative 1 would also be negative 2, which gives me an x value in my vertex of 1. Now, at this point, I have two options basically. I can either plug that 1 in, which isn't too hard in this case, and go ahead to get my y value, or if I want a little bit of a backup plan, I can go ahead, I can type the equation into my calculator and go to the table function, and if I put 1 in the middle, I should see symmetry, which I do. And I also notice that when x is 1, my y value is 5, which would complete my vertex. It also allows me to get some points quickly to be able to graph the rest of my parabola. Kind of nice. Now again, my axis of symmetry is an equation of a vertical line. You need the x equals, and then it's just the x value of my vertex. If you just write 1, that's a point. So we need to have the x equals in there. I can visually see that this opens down, which means my vertex is going to be the top of my graph, which makes it a maximum. And then I'm going to skip focus and directrix just for a minute. I'll be back to them momentarily. But my domain again, my x values, left to right, this parabola is going to continue to expand both to the left and to the right. So typically with these, that'll be negative infinity to infinity. My range, remember, is bottom to top, and that matters. Since it's going down infinitely, it would be negative infinity, but its high point is up at 5. You cannot switch those. You can't do 5 to negative infinity or 5 to infinity. It has to be bottom to top. And then finally, in this area, we will get back to our focus and directrix. Just some reminders again on what some of these values are. Focus, again, is h k plus 1 over 4a is going to be my value. Well, I already have my h, it's 1. Then here, my a value again was negative 1. So this would be 1 over 4 times negative 1, or negative 1/4. So my k is 5 minus 1/4, which would be 4 3/4. Or maybe if you went to the calculator, you get 19/4. Okay, that's okay. My directrix, its formula, if I wanted to go that route, it's going to be a horizontal line, and it's k minus 1 over 4a. So basically now, instead of being 5 minus 1/4, since my a was negative, it's going to be 5 plus 1/4, because minus negative 1/4 would make this positive. The other thing I always recognize with my focus and directrix is that they're going to be equidistant in the y value from my vertex. 4 3/4 is 1/4 away from 5. 5 1/4 is also 1/4 away. 1 is inside my parabola, and my directrix will always be outside. That's the one that's going to take the longest. For my other two, I have my vertex form. I can take straight from here. And again, just remember, it's a x minus h squared plus k. So again, to get my h, you're taking the opposite of this, which is why that became 1 instead of negative 1. So I can get that plotted. Again, if I want to go to the calculator so I don't have to do some of the other solving, that's okay. My axis of symmetry, again, will be whatever the x value of my vertex is. I notice from it being a positive a value that this is going to open up, and any time we open up, we have a minimum. Now again, if you want to plug in the values, you can do that to get your equation. But again, I like to be able to save my time to be able to do some of the other problems in case I get stuck. So I'm going to go ahead, type this into my calculator, make sure my vertex was correct, oh dear, which it is. And then again, I can go ahead and very quickly get myself several points to be able to make my expression. Again, domain and range. Domain, unless some crazy thing happens, is always going to be negative infinity to infinity. This time, though, remember, with my range being bottom to top, the bottom point would be down here at -3, and since it goes up forever, my infinity will come second. Okay. Focus and directrix are going to work the same way they did in the last one. My a value this time is going to be 2. So I look and I'm like, okay, h, k plus 1 over 4a. My k value is -3. So -3, and then my a value is 2. So 1 over 4 times 2, 1/8. So -3 plus 1/8, which would be -2 7/8. Now, if some of you, even after the last one and looking again at this one, are like, okay, where is he coming up with this stuff? You can go to the calculator with something like this. Okay? If I was going to attempt to plug this in to my, let me swing over to this side here, my k plus 1 over 4a, I could just type in -3 plus, now here's the part you got to be careful of. I do want you to do the 1 over 4a in your head before you get too far here. So 1 over 4a would be 1 over 4 times 2, or 1/8. Got to have the parentheses if you're doing it on the calculator. Do not like the decimals. You're like, okay, -23/8. That's the same thing I got here, because if you remember from mixed numbers, 8 times 2 is 16, plus 7 would be 23. If you wrote -23/8, that's fine as well. So then my directrix, again, is going to be like we did before. So since on this one, I did -3 plus 1/8, okay, here I'm going to have -3 minus 1/8. And again, I could do the same thing that I did on the graphing calculator if I wanted to, okay, with adding or subtracting the fraction. All right. Last one of these coming with the intercept. Again, my intercepts are at x equals -6 and 2. To find my vertex this time, I want to find the midpoint of those two. So I can either count in and see that my vertex x value is at -2, or I could add those up and divide by 2 and basically be looking for a midpoint. So in this case, -2, if I plug it in, would be 4 and -4, which would be -16. Half of that is -8. I have what I need for my graph. Did I just put that at -1? Oh, Harty. Tell everybody else to watch it with being careful on this, and then what do? Oh, mercy. As we can see here, our parabola is opening upward. Pretty easy to see. And then we have our vertex at the bottom, which means we have a minimum. Our domain continues to be -infinity to infinity. And since our graph here is going from bottom to top, our bottom point is at -8. And we're going upwards forever to infinity. Now one more time here with focus and directrix. As we'd mentioned before, and we'll get this jotted in here, my focus is h k plus 1 over 4a. So when I do this, I go, okay, my h value, -2, k is -8, plus 1 over 4a. Now this time my a is a half. So half of 4 is 2. So this is really -8 plus 1/2, which would be -7.5. My directrix then, and I'll talk to you again here in a minute how you might be able to come up with a shortcut for not having to do the work related with this one. But this is going to be the same as my y over here, except it's k minus 1 over 4a. So in this case, that would be negative 8 minus 1/2, which would be y equals negative 8 1/2. So remember, your directrix and your focus are always equidistant from the y value of your vertex. In other words, if my vertex y is at negative 8 and my focus is at negative 7.5, okay, right here inside my parabola, my directrix is going to be equidistant on the outside. If it's half away here, it's going to be half away for my directrix. So if you see that equidistance, then you should be pretty confident that you've got the right answer. Okay, so moving from our graphs, solve by factoring. Again, make sure on the solve, we're actually going to solve it. Again, with just an x squared coefficient of 1, I need to multiply to get negative 20 and add to get 8. I know it's going to be 1 negative and 1 positive because of the negative product. I know the bigger number is going to be positive because of the plus. And it looks like 10 and 2 would do it. And then I just set those each equal to 0. And if it's just x, it means I'm basically just going to change signs on both of these to get my solution on that one. 5, don't make it harder than it needs to be. Perfect square, perfect square, perfect square trinomial. What do I square to get my first term? 4x. What do I square to get my last term? 3. What's the sign in the middle? Boom. Set that 4x minus 3 equal to 0. And we'll go ahead and solve that. And this is one of those cases we only get one solution, because this is called a double zero. It's going to end up hitting on that spot on your graph, and that'd be the only place you'd have a 0 if you were doing this graphically. Okay, when you're factoring, now you might be able to get away with this since it's solving, but again, remember your golden rule. Golden rule states if there's something that all of your terms have in common, you need to factor that out before you start factoring. It makes this a lot easier to work with. So let's see, let's look at our hints. Multiply to a negative, one of each. Negative number is going to be bigger. Good. And again, the 3 doesn't have an x. It doesn't get set equal to 0, but each of these do. So I'm going to put 2 and negative 4 on that one. Here again, perfect squares come in handy. Difference is squares. What do I square to get 25x squared? 5x. What do I square to get 49? 7. And again, since my product is negative, I get one of each. Set those equal to 0 and solve them. So again, factoring is just number sense basically, and most of you have a really good touch on that, so that should go well. Okay, solve using square roots. I need to isolate my x squared like I did here, and if I square root it, remember, if you can break down radicals, you need to. Whenever I have a quadratic, I'm going to have 2 answers. So don't forget the plus minus. Square root of 4 would be 2 square root of 7. Nice thing about this again, if I get going a little too quick for you, you can just pause me. Here again, don't get rid of the fraction part first, because most of you forget about the 1 then. Subtract it over. Then multiply by the 5. Then you'll get your square root. And if you get one that doesn't break down anymore, that's okay. Just remember your plus minus out front and things will be fine. But again, keep working from the furthest away from the term you're trying to get along to the closest. 1/2's furthest away, 1/2 gets dealt with first by multiplying both sides by the reciprocal, which in this case is 2. Now we do get a unique situation on this one in that my x is stuck inside this quantity. So I'm going to have to square root before the very end this time, but I do get a nice break that 16 is a perfect square and breaks down cleanly. So when I bring my 3 to the other side, don't be content to just leave it like this. This is like leaving a fraction like 2/4 instead of making it 1/2. Break them down. 3 plus 4 is 7. 3 minus 4 is -1. And I'm good to go. So a lot of this it's just detail work and paying fine attention to detail, like with plus, minus, and simplifying things. And then we'll be in good shape. Okay, we got an egg dropped from a height of 105 feet. How long does it take for the egg to drop to the ground? H sub O, again, is my initial height. Where am I starting from? And then H is my ending height. So in this case, H would be 0, drop to the ground. And my initial height is, whoops, not 65, wrong problem, 105. So again, here I have 2 options on how I could solve this. I either, in a case like this, could say, okay, I'm going to do this on the calculator with the graphing function. I could use -16, I don't want to use t, I'll use x, plus 105. I could graph it and then find my 0 to see when it hits the ground. Now finding this 0 wouldn't do me any good because it's negative. We can't have negative time. So if I go to my 0 and I work my way over, there's my cursor, there he went. Okay, anywhere above, and if you really want to see more, remember I could make my y values, let's say we went to -20 and 20. You can make your window go to any size you'd like. Okay, so let's try that again. Want the 0. There's my cursor. Okay. So again, to the left, in this case would mean above, because it's to the left of my intercept right here. There he is down here on the bottom. Again, we're trapping that point in. And we find out it's about 2.56, somewhere right in there. Now, if you're more comfortable cranking it out on your own, okay, I could move my 16t squared over, divide by 16, and I could go to my calculator and do something a little bit different. Instead of doing it this way, I could do the square root of 105 divided by 16. I get the same answer. So use a way that works best for you. If you like to do it algebraically, great. If you want to do it in the calculator, great. All right, another one with our heights. So use this equation. Tomato is tossed into the air. That's why we're using this one. It leaves Brian's hand 4 feet above the ground. It's my H sub O. And has an initial velocity, my V sub O, of 35 feet per second. The tomato misses air and it lands on the ground. So notice nothing about the time. Lands on the ground is my H. How long was the tomato in the air? Okay, I need to find the 0. I need to find the x-intercept. Here, I wouldn't wish upon anybody trying to factor this. So I would go back to the calculator, let it give us some assistance. Okay, go ahead and graph it. Okay, I can see my 0 is over here. So I'm going to go ahead again, use my calculate menu to find the 0. Okay, anywhere above it is good for my left bound. Anywhere below the x-axis is good for my right, because again, I'm trapping that point in. And I find out that my 0 is going to be at about 2.3 seconds, or 2.30 if you want to do another digit. And again, that's the only way I would suggest doing that one. But again, anytime you're talking about time, how long, okay, that's going to be a 0, and that's going to be the x value. Because when it hits the ground, it's going to be at a y value of nothing. Okay? So I'm looking at the x value when I'm searching for a 0 on that one. Okay? Solved by graphing in a calculator. When needed, rounded to the nearest 100th. Okay? And again, we're doing this not because we want to get you to a point where you're doing everything on the calculator and never have to think. That is far from the point we're looking for here. But as you get ready for standardized testing and some of those other things, the speed that using a calculator allows you to get is something that's valuable. So we want to make sure you have that. Now again, this time I get two solutions, both of these zeros. So I need to find them both. Again, anywhere above it is good for my left. Anywhere below it here is good for my right, and I'll get kind of close for my guess here. So one of them would be 54 hundredths, and then I just do the process again to find my other one. Now again, this time my left bound won't be above, because if here's my point, notice I'm to the left of it. That's what the left bound is. Right bound just means I'm somewhere to the right of the zero that I'm looking for. Now get back close to the center. It looks like we're at about 7.46 for my other. All right, now this guy's a little different. What's the difference? Well, it's not an equals 0, and I need it to be. So I'm going to go ahead and I'm going to bring that 32 over. Get my y equals. Now I go to type this in. I go to graph it. I'm like, well, wait a minute. The x-axis is down here. It's not crossing it at all. You're right. What that tells me is there isn't going to be, let me change the way we write that a little, no real solutions. Okay? Still can have imaginary ones, but that's not something we're going to be able to get from solving by the calculator. So here, no reals is the better answer, but if you show me none, just to let me know that it doesn't cross at all, that would work out okay. So down below, the area of a rectangle shown is 42 meters. Area is length times width. So I've got my length times width equals the area. I'm going to distribute this out. And I'm also going to bring my 42 over, because depending on how I'm going to go about solving this, I'm going to need it this way anyway. The golden rule applies because I can take a 3 out of each of these as a factor. And some of you may type this into the calculator and find the zeros. That's a legitimate way of solving it. But this one looks like it's going to factor easy enough that I'm just going to do it that way. Let's see, one of each sign, positive numbers bigger, 7 and 2 works. So my x is 2 or negative 7, but think for a minute. We're looking for the side of a rectangle. Negative side does not make sense. Do not put both answers because, well, negative 7 just isn't right. And then my dimensions just mean plug them in. 2 times 3 is 6, plus 15 is 21, and 2 times 21 is 42. All right. A little more grouping like what we did this last time with our factoring. Remember, when you're doing these, you're grouping them, like it says there, off, looking for the greatest common factor of each pair. So here I could take a 4 and an m. I'd have left an m. I already have the 4m there and a p. So if I did this right, my quantity, my set of parentheses, the m plus p, should be the same in the next one. So here I've got a 3 and a p are in common. I need the m, got 1 p, I need 2, and that's what I'm looking for. And then my solution, my factors go together, my common quantity goes together, and I'm done. Now, sometime could I rearrange them or something if I wanted to? Sure, as long as I don't change the signs. But that's not always going to be necessary. So here I'll pair those off. I can get a 3 and an x out. 3 times 3x times 3x would be 9x squared. I already got the 3 and the x here, so I just need a minus y. Here, all I can get out, it looks like, is a 2. 3x minus y. All right. Again, your factors or half of my solution. My other quantity is the other. And I'm set. And finally, pair them off. Looks like I've got an x squared, which would leave me an x minus 4. And now let's think about signs here a little bit. If I take out a negative 5, negative 5 times x would be negative 5x. Negative 5 times negative 4 is positive 20. My common factors, what's left over, and I'm set. And then just a few to get you thinking. I like to keep coming back to the golden rule because so many times it helps out so greatly. If I take an x out that they all have in common, and then I just factor what's left. Again, I'm not solving anything here. It doesn't say solve. There's not an equals sign. So we're just going to factor it. Plus, let's look at the sign in the middle, is minus. They're both negative, and 4 and 1. Don't lose that x. Just because you take it out here doesn't mean you don't need it as part of your answer. Because I should be able to multiply this out then and get back to the original problem if I wanted to. So factor out doesn't mean divide out like it's gone. Perfect squares. B and B. 8 times 8 is 64. And to get the negative, I need one of each. Then, our new stuff. So here, the important thing is to watch for the sign in the middle. If it's plus or minus, you're just combining like terms. So like here, 12 and negative 5 is 7. 5i minus 2i is 3i. And when we talk about standard form, remember, it's your real part of it first, your imaginary part second. Now technically, is it wrong? Is it a different value if you have 3i plus 7? No, but it's the same thing where we want to get used to having things in the form. Here, the minus just means that negative is distributing through. 20 minus 13 is 7. 4i minus a negative 6i is the same as 4 plus 6i, which would be 10i. But notice when I get to 23, now there's no symbol in the middle. Now I'm multiplying. I have to FOIL this out. So as I do that, I got my first, got my outer, which is plus 27i, my inner, and my last. And just a reminder again, I squared is equal to negative 1. So really, if I plug in the negative 1 for I squared here, negative 6 times negative 1 would just make that a plus 6 and get rid of the I for me. So negative 9 plus 6 is negative 3. 27 plus 2 is 29i. And I'm good there. But I have to simplify as far as I can. And I squared being negative 1 is part of that. We talked about how you can't have an I in the denominator. Now we end up with a complex conjugate to try and get that out of there. And again, that's just a fancy way for saying switch the sign in the middle of the term I have in here. And then I'm going to FOIL both the numerator and the denominator out to get to my solution. So here, it's sort of like I'm just going to FOIL those first. Okay, so to get this out of the way. So I've got 21 minus 7i minus 6i plus 2i squared, which I know darn well is 2 times negative 1, which is negative 2. Then my denominator, same thing. 9 minus 3i plus 3i minus I squared. And I always remember those middle two terms will cancel down below, because otherwise I'd have i's left still. That's no good. And the opposite of a negative 1 is plus 1. So when I get to my solution, I've got 21 minus 2, which would be 19 minus 13i and 9 plus 1 is 10. And if something went into all three of these, I'd have to reduce. But since there isn't, I don't have to. And finally, when we get here to the end with our I to the 24th, this assumes that we understand what I squared, I to the third, and I to the fourth all equal. Because like we talked about, like, okay, I is the square root of -1. If I were to square both sides of this, that would just eliminate the radical, which means I squared is -1. Well, then how do I get here? Well, I times I squared would be I to the third. So basically, all I would do here is I would have negative I, or negative square root of -1. And finally, I to the fourth would be this term by itself. I to the second times I to the second. -1 times -1 is 1. So those are the four things that we had on that little cheat sheet that you had before to play with. And we talked before about how if I really wanted to get to I to the 24th, I could just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and just play with the boxes and get back to my answer. But there's actually an easier way. And we talked about how if you take whatever the exponent is and divide it by 4, whatever you would have left over would be which one you have. Well, if I do 24 divided by 4, that's 6. I don't have a remainder, which means the fourth is the one that I would use. But again, either way would work. And no, I won't give you like I to the 124th to make you do it this way. So hopefully that's helped out some. Again, the key's online too. If you need to make an extra copy of this and try some out on your own and then either rewatch this or go and look at the key, that'd be great. Best of luck tomorrow and good luck.